Hello, Rochelle and Thomas. I feel like it's been forever since we've spoken. Unfortunately, I do have a pretty hectic schedule tomorrow, so I'm unable to reschedule our conference call slash meeting. And it also seems as though, considering some of the difficulties we have had with the hardware requirements with using CityEngine, it may just make better sense that I just do this part so that we can move on to the next and final phase of this project, which is to finalize the 3D models. Okay, so the last video kind of walked you through the process of creating a new project, how to add data to that project, how to add a terrain. So this is the terrain that we added. And so just as a quick refresher, the way that we did that is, you can't see on the screen, but if you go to File, Get Map, and you have to be signed in to the ArcGIS Online account that I set up for you guys. And it's okay that you both have the same sign-in. And then after you sign in, you can search an area, and then using this tool here, you can draw a boundary for where you want your 3D model to be. And the last video, we walked through the process of, as I mentioned, creating the project and then dragging and dropping data. We dropped in tile number 5. And we walked through the process of creating 2 CGA scripts, which is the tool that this program uses to generate 3D objects from two-dimensional shapes that have data attached to them. And that's essentially what GIS is. It's a two-dimensional. It's the two-dimensional shape that has a lot of information, like an Excel spreadsheet attached to it. So, for instance, the building, you guys saw that each building footprint, we had a lot of information attached to each one of those building footprints. So we use that information to generate 3D objects. So the next phase of this work would have been for you each to take the tiles that you were assigned and the buildings that you were assigned and follow the steps that we did in a previous video with tile number 5 that you see here, the only 3D tile that you see here. So that's tile 5. So I'm just gonna I'm just gonna do the process, and then I'm going to provide you with the 3D files and ask that you work together in CAD and Tinkercad to finalize the next steps. Okay, so I've dragged and dropped every single tile and all of the buildings for each tile onto the 3D viewport here. And I've grouped them. And to create a group, you just right click in somewhere in the gray area in your scene menu and select new group layer, name it, and you can just drag and drop layers into it. So I have all of my tiles in one group, and I have all of my buildings in another group. So this process is really quick to convert your 2D data to 3D models. But first what we need to do is we need to align everything to the terrain. Everything comes in at the 0 axis. Of course, land is always at some point above seawater. And so we have to align the shapes that we brought in to where this terrain actually is. So in order to do that, you just select everything. So select objects. And then there is a Align Shapes to Terrain button. You click on that and you want to project all, which means for each vertex point within each shape, I want you to drape it onto my terrain. And the height map, right now y = 0 is what we don't see. Our terrain from the satellite imagery is what we want to use. Great, now everything is aligned to our terrain. The next thing we want to do is we want to extrude these 3D shapes, these two-dimensional shapes into 3D objects, or convert two-dimensional shapes to 3D objects. We created a CGA script for buildings and a CGA script for tiles. And if just to go through that building script, basically what we're doing is we're attributing the rule so that this allows the CGA script to pull data from the buildings data attributes, and that would be stories and roof type. And we're telling the first function in this rule is to take the shape that represents the building footprint, extrude it by stories multiplied by 4.3. So that gives us about a 12-foot ceiling. This is in a metric system. So this is the factor we use to multiply and convert stories into metric. So we're extruding it by 4.3. And then after you extrude it, I want you to split the shape, the mass, into what is considered its sides, its tops, and its bottom. And then after you do that, I want you to take the top and turn turn it into a roof top, depending on what we have in our roof type attribute. So right now we wrote the rule to say roof type attribute is equal to flat, meaning everything's going to get flat unless it has something in a data set which you collected, unless it has hip, gable, pyramid, or shed in its data set. Okay, and then the tile rule is a little more simple. It's simply just take the shape and extrude it by a negative factor. Great. So what I want to do is I can apply a rule to hundreds of features at a time. And this is the way that 3D models are created today. The old school way was to, as I mentioned in my previous email, was to manually extrude each building individually. But typically you don't see people modeling that way anymore. That's kind of like, as I mentioned, the old school way. So that would be where I would take this and I would, I would take this shape and I would either extrude it up or down and then do more manipulation to it. But we're not going to do it that way. We're going to do it the new way. So right click, if you right click all of the buildings and then you say select objects, so right click and select objects, you can then take the extrude building rules and drag and drop it onto the objects that are selected. It may take a few minutes to populate, but what you'll see is that all the buildings, each footprint is now checking its internal data and then generating a 3D model based on the rule that we wrote. Okay, and that looks like it's all accurate. What you want to do is you want to check your model to see if there are any maybe buildings that didn't generate for any reason, and do some quality control checking. Like for instance, there's this building here. Okay, so this was a note that you guys took that I missed, which was that this building is torn down. So I would go and I would delete that building from the data set. And this one, I'm not sure why it didn't get. There's no notes here and there's no height. Yes, there is. Okay, so you would do some, I won't take up more of the video time doing this, but you would do some quality control checking for any buildings that maybe didn't come in with height. I think that most of our buildings came in just fine. A couple that I need to do a little bit of quality control checking with. And it might also be a good idea too to just do a comparison to an aerial imagery. So I'm just going to pull up. And the reason you'll want to do this is you want to see if there are any maybe certain buildings that you missed, like high-rise buildings that really kind of like stand out and should be included. Like for instance, do I have these tall buildings here? Just want to make sure that my model is complete. And I think think it is. Yeah. Okay. So once you did your quality control, and of course you guys won't have to do this step. I'm doing it for you, but I strongly encourage that you continue to play around with City Engine. I will try, as I mentioned, I can get you a ESRI license if you have a .edu email address. It's really easy for me to do, but if you don't, then it requires me kind of asking for some favors, which I'm happy to do. So if you want to play around with City Engine more, let me know, and I'll keep working on finding ways for you to have access to the license, and maybe you can. The issue is hardware. This is a gaming program. This program is how movies like Avatar and Cars, the scenery that you see in those movies were created using City Engine. So the graphic card requirements are pretty high. It's a very intensive program. So anyway, okay, so we have all of our buildings are extruded. Now what we want to do is we want to extrude all of our tiles. So again, you can right click and select all objects. You can also select it this way, just kind of draw a marquee over them, and then you take your extrude tile rule and you assign your extrude tile rule. All right. So now the next step to this is once you've applied your rules and you've extruded it, the model is complete. Except we're missing buildings for tile 45. Okay, so I just added in buildings 45. I extruded them. Now what I'm going to do is apply my rule. So you see, all you have to do is just simply apply a rule. Extrude buildings rule. Okay, and then add that to my group. Okay, now the model is complete. So the next step is to export all of these models out as a .obj. And the way that you do that is you just select this object, which is all of your buildings that are on tile 18. Then you can't see it, but you go to File, Export Models. And there are different formats that you can export them as. You can export them as a KML if it's going to like a Google Earth. You can export them as a ESRI multi-patch, a collada to be used in SketchUp. And what we're going to use is, you can even do a FBX if it's easier for you. I'm actually going to provide you both a .obj version of everything and a .fbx because I think you guys have access to Autodesk, and it may be easier to use Autodesk to clean up the models. So anyway, so you would select which format you want to export your model as and click Next. This was tile 18 buildings. So this is going to be important part that, of course, I'm doing this, but if you were doing it, you would want to make sure that you're naming everything correctly. So it's buildings, and there are buildings on tile number 18. And do not export. I don't want to export the terrain. I only want to export the models, the actual 3D element that we're seeing. I don't want to export the 2D element. And that is all, I think. Discard holes. That has something to do with how it triangulates the model. Okay, click Finish. And now the model should be in the project folder. And so the next step of this work would be, so after you would export, so it takes, just a couple minutes to apply the CGA script, generate the 3D rule, and then it takes a few more minutes to export each model as an individual element. So you would get a Tile 18 base model, a Tile 18 buildings model, and you would then use Tinkercad to bring those models together and clean up the geometry. And what I mean by that is, bear with me while I pull up something here. Okay, so I went to the source file of where this model is that I just saved, the buildings.obj. Oops. And what I want to do is that's not what I want to do. I want to preview it. Here we go. Okay, so this is actually a pretty clean model, but there's certain elements that need to be cleaned up. Like, for instance, you see this corner here, there's like a little, or the tops of some of these buildings are, as you can see, is a little triangulated. So for instance, when the 3D printer tries to print this model, it'll print this building just fine, but this building you may have a problem with because it's triangulated. Why is that happening? I'm not sure, but it's something that the 3D printer doesn't like. And so this is the next phase of the work, is to come up with a process to clean up the buildings. A lot of these are going to come in just nice and clean, but some of them will not. So the process to clean them up is kind of outlined in an email that I sent on May 22nd. So I'm just pulling up that email now. So what you're going to have is you're going to have a separate 3D model that is the base called Tile 18, and a separate 3D model that is the buildings to go on top of that base. And for Tile 18, it'll be called buildings _ Tile 18. And the next step is to use this program called Tinkercad to bring the models together in a 3D element and do some cleaning up. So this is something that I don't have a lot of experience working with Tinkercad, but Elizabeth does. So I recommend that the first few hours that you spend working on this next phase, do it while during Elizabeth's office hours, because if you come up with questions, she'll be there to help you out. So you're going to bring in first figure out which works best, right? Is it going to be the FBX model, or is it going to be the .obj model? Which one works best? And what you're going to do is you're going to bring it into Tinkercad. The ultimate goal is we need a STL version of the models that is a clean STL version of the model, a .stl. So the format that we currently have is .fbx or .obj, and we need a .stl for the 3D printer. Okay, so that's pretty much it. Those are the next steps, is for you to take these 3D models and start working with them in Tinkercad. And again, try to do it while Elizabeth is there at the Polsky Center, so you have a little bit of support if you if you have trouble for any reason. Coordinate with Elizabeth, let her know that, hey, I'm going to start working on this next step, which is to clean up the 3D models. In case I have help, would it be a good time to come between certain hours of a certain day or whatever? All right, so this is what I was planning on going over during our call, so I'll just go ahead and send this to you. Please feel free to reach out to me if there's anything I can do to help. And thank you so much for your patience. I know it was difficult to try to get past the CityEngine hardware struggles. And of course, if you are really interested in continuing to work in City Engine, I teach this full time at Philadelphia University. I'd be more than happy to help, help you get exposure to this somehow, in any way that I can. All right, Rochelle and Thomas, thank you so much, and I look forward to speaking with you soon.